Okay, hi everyone. Good afternoon. I'm Maria Klein, and with thanks to my co-authors, I'm going to share our work on the relationship between an unconditional cash transfer program and prevalent metabolic syndrome in South Africa. So metabolic syndrome is not a disease in and of itself, but is a clustering of interrelated factors. These factors are elevated waist circumference, elevated triglycerides, reduced HDL cholesterol, elevated fasting glucose, and elevated blood pressure. A co-occurrence of at least 3 of these conditions predict higher risk of many serious health outcomes. Therefore, it is important to understand what drives MET's prevalence. So it's estimated that more than 1 billion people worldwide meet the criteria for METs, with prevalence of its 5 component conditions continuing to grow. Rise in METs is often attributed to spread of Western lifestyle behaviors such as smoking, sedentary activity levels, and higher consumption of refined and processed foods. However, some settings in low and middle income countries have high prevalences of METs alongside low prevalence of these common risk factors. Here, other risk factors may take precedence, like lower education, lower income, and food insecurity. The association between socioeconomic factors and METs points to the potential for cash transfer programs to be used in prevention efforts in these settings. So, could cash transfer programs be an effective prevention strategy? The short answer is one of our favorite phrases in epidemiology. It depends, or as we heard earlier, it's complicated. In theory, cash transfer programs could raise living standards and improve health outcomes. But in practice, the direction of cash transfer effect likely depends on how the cash transfer funds are used by recipients. There is little empirical evidence on the association between cash transfers and METs in low and middle income countries. Associations with some METs component conditions may provide signals as to the probable relationship. No change or decreased risk of overweight is generally found in children, but increased rates of hypertension and obesity have been found among mothers in households receiving cash transfers. In terms of people served, the South African Child Support Grant Program is one of the largest unconditional cash transfer programs in Africa. The CSG program offers a small per child grant to income eligible households, which is predominantly spent on food. Its evaluations have shown, like other cash transfer programs, that it is successful in improving child health outcomes, but its relationship to the metabolic health of its adult recipients has not been assessed. Which brings us to our research question. Is duration of CSG eligibility associated with METs in Black South African women over time? To investigate, we first established METs prevalence in a cohort of Black South African women, then estimated the longitudinal association. As mentioned, cash transfers could plausibly influence risk of METs in either direction, but based on the observed associations with METs component conditions from other low and middle income countries, we hypothesized that we would find a positive relationship. The study setting is Agincourt, South Africa, an area to which Black South Africans were forcibly relocated during apartheid. The study data comes from the HAALSA Indepth component of the ongoing Health and Aging in Africa Longitudinal Studies in South Africa portfolio of research. Of the 5,059 HAALSA Indepth participants in Wave 1 who were interviewed between 2014 and 2015, 2,713 were women. For our study sample, we restricted to women aged 40 to 59 and with fewer than 10 children to reflect the typical childbearing patterns in Agincourt area mothers. The exposure was calculated as the potential cumulative years of CSG benefit for each mother, aggregated for all children, all of her biological children, and then divided by the number of CSG eligible children. And we're calling this PCSG or potential CSG. So PCSG duration is based on children's birth dates and then cross-referenced against the CSG age eligibility cutoffs since the program was introduced in 1998. When the program began, only children under age 7 were eligible, but incremental expansions ending in 2012 increased eligibility to all children under age 18 in income-eligible households. So this exogenous variation due to the expansions in eligibility age creates a natural experiment in which the variation in PCSG is primarily due to differences in children's birth dates among households with similar age and size structures. The outcome at wave 1 and wave 3 was established using point-of-care measurements for each component condition. It's a little bit different than Helene mentioned. It's not hypertension itself, it's elevated blood pressure, so it would kind of be that pre-hypertensive phase. In addition to the other component conditions, kind of like the pre-conditions of each of these, like, diabetes. It's not a true diabetes, it's an elevated fasting glucose. But we use the thresholds from the 2009 Joint Interim Statement METS definition. And this definition recommends using ethnic or population-specific thresholds for waist circumference. So we used 92 centimeters as our cutoff point as established in optimization studies, specifically for Black South African women, conducted by Motala et al. And Crowther and Norris. We additionally used a glucose measurement threshold of 7.8 millimoles per liter for participants who were non-fasted or who had missing fasting data to establish an elevated blood glucose status where we couldn't establish a true elevated fasting status. We estimated prevalence using log binomial generalized models. We inverse probability weighted the wave 3 prevalence estimates to account for attrition and refusal of measurement. To estimate the PCSG relationship, we used log binomial and modified Poisson generalized estimating equations clustered at the individual level to account for correlation in individual responses between the two waves. We additionally weighted for mortality and adjusted for several sociodemographic factors. Among our study sample, the average age was 51 years old. The average woman had 5 children and a median PCSG value of 9.38 years per eligible child. The prevalence of METs among all women at wave 1 was 44% and increased to 57% by wave 3. In the study sample, wave 1 prevalence was 42% and increased to 55% by wave 3. The slightly lower prevalence in the study sample was expected due to the lower average age within the study sample. There was no significant difference in METs prevalence when comparing women with above median PCSG to women with below median PCSG, either at wave 1 or wave 3, with similarly null relationships in most subgroup analyses. We did find that above median PCSG was associated with a faster increase of METs prevalence among higher education women. To sum up our findings, although METs has previously been characterized as a disease of affluence and social development, METs prevalence among rural Black South African women in a low-income setting is high. There are several potential factors that could be contributing to the high METs prevalence among Black South African women, including genetic, cultural, comorbidity, socioeconomic, and nutritional factors. And although we did not find an overall association between PCSG and METs, There are multiple pathways by which cash transfers could potentially affect risk for METs that may not be present within HAALSA, the HAALSA Indepth CSG households, including differential healthcare utilization, stress levels, and nutritional intakes. As Helene observed, the infrastructure is not quite there for chronic disease management, and that is coming through in the healthcare utilization data for the HAALSA Indepth cohort as well. In considering key limitations, misclassification of the outcome is possible due to inaccuracy of point-of-care measurements or inaccuracy introduced by our analytic choice to dichotomize continuous component conditions to create a binary outcome. A sensitivity analysis using different waist circumference thresholds than the ones we selected did result in the same conclusions with similar point estimates and confidence intervals. Additionally, our analyses were likely underpowered for stratifications within the parity subgroups. 2 additional waves of HAALSA Indepth data are forthcoming and may help determine if the faster increase in prevalence change that we observed for higher education women actually results in increased prevalence that persists over time. So in conclusion, MET's prevalence is high and increasing among Black South African women, and in a departure from other South African METs studies, elevated blood pressure and not reduced HDLC is among the most common component condition. Higher exposure to CSG is not generally associated with increased risk of METs, as we originally hypothesized, based on evidence from other low and middle income countries. However, in its current form, this cash transfer program also does not appear to offer any direct benefit to adult metabolic health in the form of decreased METs prevalence. Further research using different cash transfer programs and populations is needed to elucidate the multiple pathways by which cash transfers could influence METs risk. And thank you for your attention. Special thanks to these folks.